Hi, 8th grade. Welcome to lesson 1 of topic 3, understand relations and functions. By the end of the lesson, I want you to be able to say, I can tell whether a relation is a function. Let's solve and discuss it. The 10 members of Photography Club want to raise $500, so they will hold a raffle with donated prizes. Jesse proposes that to reach their goal, each member should sell 50 raffle tickets. Alexis proposes that each member should raise $50. Whose plan would you recommend? Explain. All right, take a minute and figure out what could happen with Jesse's plan and what could happen with Alexis's plan. Pause video and press play when you're ready. Okay, with Jesse's plan, they need to sell 50 raffle tickets. Well, there's multiple ways that we could do that. If each person sells 50 tickets at $1 a ticket, that would be $50 a person. And there's 10 people, so that would be $500. That would work. But what if each person sold 25 tickets, but like using this one at a time, or 25 tickets at a time? Well, 25 tickets is $20, so if they sold 50 tickets, they could sell 50 tickets for $40. And if each person only sold $40 times 10, that would equal $400, and that would not reach their goal. With Alexis's plan, if each member just raises $50, no matter how many tickets they sell, times 10, that would get them to their goal of $500. So I would recommend Alexis's plan because you would still hit your goal. You might hit your goal with Jesse's, depending on how you sell the tickets, but Alexis's is more sound. How are the two plans different? How are they similar? Okay, they are different because with Jesse's plan, it depends on how you sell the tickets. So it depends on how many you sell at a time. Similarities, they're both raising money. All right, example number 1. Identify functions with arrow diagrams. Jonah is shipping 5 boxes for his uncle. Each box is the same size but a different weight. The cost to ship each box is shown. Should Jonah expect that the cost to ship a 15-pound box will be a unique cost? Is there a relationship between the weight of the box and the cost to ship the box? So here, the input or the X value is the weight, and the output is the Y value. If you've ever taken anything to like UPS, they weigh it first, and depending on how much it weighs, they tell you how much money it is. So usually something that is heavier costs more because it's harder to ship. So an 8-pound box weighs an 8-pound box costs $8.56. 9-pound box costs $8.72. Any sort of ordered pairs is a relation. That is one of your vocab words. Step 2, use an arrow diagram to match each input value to each output value. Input is X, output is Y. So they draw arrows straight across from the weight to the price. So this is the weight in pounds, and this is the cost in money. So see how the arrows go straight across? A relation is a function when each input is assigned exactly one output. This is huge, this definition. Learn it, live it, love it. For each input above, there is exactly one output. So the relation is a function. Jonah can expect that the cost to ship a 15-pound box will be unique. So if someone ever asks you if a relation is a function, your answer is yes or no, because every input does or does not have one output. So everything you put in only has one number that comes out for it. We'll see more examples where that does and doesn't happen so we can get used to it. Let's try it. Joe needs to advertise his company. He considers several different brochures of different side lengths and areas. He presents the data as ordered pairs, side length and area. So this is the input, or the X value, and this is the output, or the Y value. So we can see here 2 draws an arrow to 20. That's already taken care of. Let's do 4 is my X, and the output is 24. So I'm going to draw an arrow to 24. Then there's 5, 35. So from 5, I draw an arrow to 35. 8, 24. I got to put an 8 in my inputs. Draw an arrow to 24. And 9, 27. 9 to 27. Complete the arrow diagram. Is the area of brochure a function of side length? Yes. And remember, we're going to use our definition again. Yes. Every input has one output. So every X only has one arrow drawn from it. Convince me. There are 2 outputs of 24, and I hope some of you are getting a little bit confused by that. 24 has 2 arrows pointing to it. Does this help you determine whether the relation is a function? Explain. No, because an output can be used more than once. So it's okay for an output to be repeated, but the inputs cannot repeat. You should never have an X value that repeats. An easy way to check that is just to look at all your X values. 4, 5, 8, 2, 9. None of the X values repeated, so we are okay with that. Example 2. Use tables to identify functions. Frank uses a table to record the ages and heights of 6 students he tutors. Is a relation a function? Explain. So you have to determine whether each input has exactly one output. If we look at the X values, those are our inputs. I can see that there's a 9 and a 9. That is the same input, but the outputs are 54 and 61. So that means that 2 9-year-olds have different heights, and it is not a function because that input of 9 has 2 outputs. Again, it happens with 8 and 45, and 8 and 50. 8 is the same input, but you put 8 in, you get 45 out, or you put 8 in and you get 50 out. There's more than one output. So because 2 inputs have more than one output. Try it. Frank reverses the ordered pairs to show the heights and ages of the same 6 students. Is the age a function of height? Explain. So now our input is the height. That's our X value here. That's our input. And our output is age. So we're looking, okay, we've got a height of 54 and a height of 54. So it is the same input, but if you look, we've got 2 different outputs. So that tells me no, it's not a function because there is more than one output for the input 54. Okay, so again, remember an easy check is that the X values repeat. But that's not good enough for the explanation. You can't say because the X values repeat. You've got to say there's more than one output for the input. Interpreting functions. Heather and her parents are going in an art museum for the day. The parking garage near the museum charges the rate shown in the sign. Is the cost to park a function of time? We got 1 hour, that goes to 5, 2 that goes to 10, 3 that goes to 15, 4 to 20, 5 to 25. So none of my inputs, my times, repeat. So every input has one output. So each hour of parking time has a different cost. So the cost to park is a function of time. That word function. If they stay at the museum for 6 hours, should they expect to pay more than $25? Well, if 5 hours is $25 and it keeps going up every time, yeah, 6 hours is going to be more than $25 because it keeps going up. Heather claims that she can tell exactly how long a family was at a museum by how much the family pays for parking. Is Heather correct? Explain. Pause the video, say yes or no, and why. Okay, hopefully you said no, because if they stay for 2.5 hours, they still pay for 3 hours. Because you do it up to 3 hours. It'd be past the 2 hours, up to 3 hours, they'd have to pay $15. All right, key concept on the next page. A relation is a function. Here we are. Here's our definition. Each input corresponds to exactly one output. You can use an arrow diagram or a table to determine whether a relation is a function. So this one is a function because if you look, the arrows go straight across. It doesn't branch off into 2 different arrows. I'll show you what it looks like to be not a function with an arrow diagram. Because here we can see it on the table. There's a 2 with a 4 and a 2 with a 6. The input is 2, but it has 2 different outputs. Could be 2 with 4 or 2 with 6. That's no good. If we had an arrow diagram, we would just use 2, 4, and 5. And then we'd have 4, 6, 8, 10. And I draw a line from 2 to 4 and from 2 to 6. The input can't have 2 arrows. It can only have 1 arrow going across. So then it's 5, 10, and 4, 8. All right, 8th grade, let's say it. I can tell whether a relation is a function. Have a great day.